Now, what if you already have the area under the normal curve you'd like, but you want to find the z-score or x value that gives you that area in the Ti-84? Well, you can do that too, using second vars to distribution, so distribution, and we'll go down to the inverse normal. So that's the 3 here, we'll press enter. If we want, for example, 50% of the area to be less than the value, let's say we're using the standard normal, so we'll get 0 and 1. Well, that's going to give us exactly 0, right? The mean. So if we want, for example, we'll go down to inverse normal. If we want 30% of the area to be less than the value, we're looking for a z-score. For a z-score, you use mean of 0 and standard deviation of 1. So we'll go down and paste, hit enter twice. We'll have a z-score of minus 0.5244, gives us area 30% less than that z-score. And you could double check this using the normal CDF if you'd like. If you want to go up to what we had before was minus 0.5244. So if we wanted to go up to minus 0.5244, we get, hey, guess what? 30% of the area up to that value. Very good. Now let's say we're talking about a group of people whose heights are normally distributed with mean 70 inches and standard deviation 5 inches. Maybe we'd like to know what height is the 90th percentile. So what height is taller than 90% of people in the group? So we'll go to second distribution, inverse normal, and then we'll say we want 90% of people less than this value. So 0.9 is the area we'll put in. The mean, the average height is 70 inches and standard deviation is 5 inches for this group. So we would have to be 76.4 inches tall to be in the 90th percentile for this group. Now let's say we want to know the 5th percentile. Instead of typing everything again, we could just go up to and copy this command. What is the 5th percentile, only taller than 5% of the group? Well, I'm going to do insert, so second delete gets to insert, and I'll put 0.5 because that's 5%. And then I'll get out of that, just moving one of the arrows. And then I'll delete this 9. So now we're looking for the inverse norm of 5% area below this x value, where the mean is 70 and standard deviation is 5. Let's hit enter and find out. So if you are 61.8 inches tall, then 5% of people in this group are shorter than you, and 95% of the people in the group are taller. Now, let's say test scores are normally distributed with mean 70 and standard deviation 10. We'd like to find out if 80% of the people passed the test, what was that passing score? So 80% of the people were above some score, which means we should find something that 20% of people were below. So let's do second distribution. We'll go down to inverse normal, boop. Then we'll see what has area 0.2 or 20% below this value. The mean is also 70, but now the standard deviation is 10 for this test score example. So it looks like if you got a 61.58 or higher, then you passed the test because 80% of people got above a 61.58.